Welcome to this episode of Robert's Creative Chronicles. So today we'll be solving this question which states that the armature of a DC machine has a resistance of 0.1 ohm and is connected to a 230 volt supply. Calculate the back EMF when it is running I as a generator giving 80 ampere, 2 as a motor taking 80 ampere. So before we start these two, I want to show you how a generator circuit is and how a motor circuit is. For example, let's draw a long shunt generator. So this is the generated EMF. So this is the load resistor RL. This is the shunt resistor. Sometimes you can write this RSH as RF. Here is the series resistor RSE. Here is the generated EMF. In generator it is known as generated EMF. Then this is the armature resistance. Then this is the armature resistor RA. Here is the armature resistor RA. So in a generator, let me write generator. In a generator, the current from this EMF flows, in a generator, the current from the armature, from this positive terminal, flows upward. It is known as IA. It flows, that is the armature current, it flows up through this series resistor, and when it comes to this point, it divides into two. That is the shunt current, ISH, or you can write it as IF. Then here is the road current. Here is the road current IL. So if you use KCL here at this point, IA is equals to ISH plus IL. That is IA is equals to ISH plus IL. So now in a motor, this direction is reversed. Let me draw it. So while in a motor, the current does not come from the armature in this long shunt motor. Instead, it comes from this road resistor. So the current comes from the road, is known as IL, and it enters this node and splits into two. Here is IA, then here is what? ISH. So now in this case, if you apply KCL here, it will be IL is equals to IA plus ISH. So you see the opposite. And here, the EMF is known as the generated EMF. The EMF is known as the back EMF, EB, not EG. So here we call it the back EMF. That's why it changes from EG here to EB. So this is the difference between a generator and a motor. When you are solving questions on DC machine and they give you a motor or a generator, you must consider this. You must consider this current flow. So let's start with the first one. So we have to calculate this as a generator giving 80 ampere. So the formula we're going to use is what? EG is equal to P plus IA RA. V is 230 plus, what is IA? 80. Then RA, which is the armature resistance. This is the armature current. IA is the armature current and RA is the what? Is the armature resistance, which is 0.1. Is 8. So this is what? 238. So this is 238 volts. So this is the EMF generated when it is running as a generator giving 80 ampere. Then for a motor taking 80 ampere, and the EMF for this generator is called the generated EMF. So this, for a motor, it's called the back EMF, EB. This is the generated EMF. And the formula is slightly different from this. Instead of plus here is minus, so it will be V minus IA RA. So there is a minus for a motor, there is a minus here. So it will be what? 230 minus 80 times 0.1. That is 230 minus what? Minus 8, which is what? 222 volts. So we have successfully solved this question. This is the EMF generated when it is running as a generator giving 80 ampere, and this is the EMF generated when it is running as a motor, taking 80 ampere. And I want you to note that the two circuits drawn here are not the circuits for this question. They are just examples I'm trying to give to show the directions of a generator's current flow and a motor's current flow. This is a long shunt generator and this is a long shunt motor. So these two circuits, they are examples to show that in a generator, current flows from this armature to these two resistors, and in a motor, current flows in another way from this resistor from here and enters this armature and this shunt. So it's just for better understanding of motor and generator circuits. This is the solution for this, and this is the solution for this. So you don't need to draw these circuits. These circuits are just examples to show you the directions of current flow. These are the solutions from here. For I, as a generator giving 80 ampere, this is the solution. Then for the second one, this is the solution. So that's it. So I hope you understood this episode. If you have any question, feel free to contact me using my WhatsApp or email it in the description below, or you can write them in the comment section. Thank you for watching. Please don't forget to like, share and subscribe to my channel, and hit the notification bell to get notified as soon as I drop a new video. Thanks.